Okay guys, Mr. Burns here, and we're talking about polynomial end behavior. First thing we got to realize is that the end behavior is based upon two things. The first is the degree of the polynomial. Okay, you'll remember that the degree is equal to the highest exponent. And what we are mainly concerned with is if this highest exponent is odd or even. The next thing that is based upon is the leading coefficient, whether it is positive or negative. Okay, so now let's look at odd degrees first. So polynomials with an odd degree, some examples are x cubed, x to the fifth, x to the seventh, and they can be any, these would be your degree of the polynomial. Notice how they're all odd. So for this we have a general shape. The general shape for an odd polynomial is they are going to start low and they are going to end high. So as x goes towards a negative infinity, f of x goes towards a negative infinity. As x goes towards a positive infinity, f of x goes towards a positive infinity. And these are if your leading coefficient is positive. Okay, so now that brings us to our next situation. Is if our leading coefficient is no longer positive, it is negative. So with the leading coefficient being negative, the general shape of our graphs are going to start high and end low. So as x goes towards a negative infinity, f of x goes towards a positive infinity. As x goes towards a positive infinity, f of x goes towards a negative infinity. Okay, so you can see with an odd function, they're always going to be opposite in terms of end behavior. It's either going to start low and end high, or start high and end low. The leading coefficient is positive is when we're starting low and ending high. The leading coefficient is negative is when we're starting high and ending low. Another thing to realize is that the only way that we can have end behavior that is opposite of each other is we are guaranteed to have one real zero with an odd function. Okay, so now let's look at even functions. Okay, examples of even functions are x squared, x to the fourth, x to the sixth, and x to the eighth. And once again, these would be the degrees of our polynomial. So these would be the highest exponent that is present. What this does is it gives us a general shape that is parabolic. Okay, and if the leading coefficient is positive, our graph is going to look like this. Okay, and you can see that both of our ends are going to be approaching the same value. So as x goes towards a negative infinity and positive infinity, f of x goes towards positive infinity. And once again, it's talking end behavior. So what's going on as we go farther and farther left from the origin and farther right from the origin. Okay, if the leading coefficient is negative, your graph has this general shape. Where as x goes towards a negative infinity and positive infinity, f of x goes towards negative infinity. Okay, so you can see with an even function, both of our ends are going to be approaching the same value. Since these are a parabolic shape, this allows for any amount of zeros. An even function can have no zeros, where the graph starts above the x-axis and goes up. It can have 2 zeros, where the graph starts below and goes down. It can have 3 zeros, 4 zeros, 5 zeros, but generally even functions will have an even amount of zeros, whereas odd functions will have an odd amount of zeros. Okay, and then if you're looking at domain and range for an odd function is all real numbers for the domain and all real numbers for the range. For an even function, the domain is all real numbers, while the range is cut off by a maximum or minimum value that appears at the vertex.